and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. Friends, today's video is part 9 of Thermodynamics class 11. In this part, we are going to study about heat capacity, molar heat capacity, specific heat capacity and relationship between Cp and Cv. So let's start without wasting a minute. Come up to first thing, heat capacity. So this is denoted by capital C. First thing. Now, in general terms, what is heat capacity? Heat capacity means the amount of heat, or we can say the capacity of a substance to get heated up is called its heat capacity. Okay. Let me explain in some other words. How can you heat up a substance? By giving heat to that substance. And now, how can you know that the substance is heated up? By measuring the temperature. Correct? It means there is the relationship between the heat and the rising temperature. So we can say the increase of temperature of a system is proportional to the heat transfer. We can write the heat transfer or heat absorbed is directly proportional to the rise in temperature, that is delta T. To remove this proportion sign, we have to add some coefficient. So Q is equal to coefficient into delta T. This coefficient we can write capital C into delta T. Now we got a relationship Q is equal to C delta T. Here the C is called our heat capacity. Clear? Now let's understand the property of the heat capacity. So the magnitude of the coefficient is the value of heat coefficient that depends on the size of the substance, composition of the substance and the nature of the system. Okay. Since it depends on the size or we can say amount of the substance, we can say that heat capacity is an extensive property. Because we already studied that extensive property are those properties which depend on the amount or the size of the substance. Okay. Now, one more important point to understand better heat capacity is heat capacity is large. If the heat capacity is large, there is a small rise in temperature. So, substance whose heat capacity is large. So, we have to give a big amount of heat to rise the temperature. Understand? Let's have an example of water and sand. Water heat specific is very high. It means to rise the temperature by 1 or 2 degrees centigrade, we have to provide a big amount of heat to the water. Clear? On the other hand, sand has low heat capacity. It means with a small amount of heat given, the temperature change will be very big. Since heat capacity is the ability to heat up, the capacity to get heated up. So, the sand capacity to heat it up is low. It means little amount of heat gives a big rise in temperature. On the other hand, water heat capacity means the capacity to heat it up is very high. So, to give a temperature difference, we have to give a lot of heat there. This is the use of heat capacity. Understand? It depends on the size, it depends on the composition, it depends on the nature of the system or substance. So now, let's come up to the specific heat capacity. Now, the quantity of heat required to raise the temperature of 1 unit mass of the substance by 1 degree Celsius or Kelvin is called a specific heat capacity. So it is an intensive property because now this depends on, or we can say this doesn't depends on the amount of the substance. So it is not intensive property. This is denoted by small c into m. We can say small c into m. Let's understand. Suppose if we have to measure the heat Q to raise the temperature of any sample. Okay, so how to write? To calculate Q to raise the temperature of any sample. Now here we are not talking about the 1 gram per gram. So it means Q is equal to small c, specific heat capacity, into mass into delta T. So we can write the heat capacity in like this way. And already we knew that Q is equal to C delta T. It means we can make a relationship between specific heat and the heat capacity. It should be C into M is equal to capital C. We can write. It means specific heat capacity multiplied by the mass of the substance, that we will get the heat capacity. So here also we can explain the heat capacity depends on the mass of the substance. And specific heat capacity is equal to heat capacity divided by mass. It means specific heat capacity is independent of mass, so it is an intensive property. Now come up to molar heat capacity. Now definition says the quantity of heat required to raise the temperature of 1 mole of substance by 1 degree Celsius. So here we can say the molar heat capacity, which we will denote by C subscript M, multiplied by number of moles is equal to heat capacity. We can define the molar heat capacity like that. Or we can say molar heat capacity is equal to heat capacity upon number of moles of the substance. All the two ways are correct to define the molar heat capacity or heat capacity. So in this way we understand the molar heat capacity means heat capacity per mole of substance, and specific heat capacity is the heat capacity of per gram of substance. This difference is there. Now come up to the next and very important part, relationship between Cp and Cv of an ideal gas. Now here let me explain you what is Cp. Cp is the heat capacity at constant pressure, and Cv is the heat capacity at constant volume. Now for an ideal gas we are going to study. Now we knew already that Q, or we can say QV, heat absorbed at constant volume, we can write QV or Q, both are correct, is equal to delta U. We studied this thing. Yeah, already we studied. One more thing we studied, that QP, heat absorbed at constant pressure, is equal to delta H. Okay, now we are going to use this. So in place of QV, we can write, we studied Q is equal to C delta T. Now apply this in place of Q. We can write Cv delta T is equal to delta U. Same here, Qp we can write Cp delta T is equal to delta H. Now from the change in enthalpy formula, just remind that delta H is equal to delta U plus delta PV. Now PV, we studied that for ideal gas equation, we studied that PV is equal to nRT. For 1 or mole of gas, we can write PV is equal to RT because N is 1. We can write for 1 mole of gas, of ideal gas. Okay, so we can write in place of PV, we can replace it with RT. Delta H is equal to delta U plus delta RT. Now, delta H is equal to delta U plus. Now, R is a constant, so delta concept won't go with that because delta means the change. R is constant, so we can write delta T only. Correct? Now, replace delta H and delta U from the given, not here, from this, not this, sorry. So, in place of delta H, we can write Cp delta T is equal to delta U, we can write Cv delta T now plus R delta T. So we can write delta T. Sorry, what I am writing? Cp delta T is equal to Cv plus R delta T. Now delta T cancel out. What is left over here? We can measure here Cp is equal to Cv plus R, or we can write Cp minus Cv is equal to R. Now here comes the relationship between Cp and Cv. Cp means heat capacity at constant pressure minus heat capacity at constant volume is equal to a constant R. So friends, that's all for today in this video. Hope you guys like the video. If you have any doubt, please do write in comment section. Till then, please like, share and subscribe the channel. Thank you.